What's up? This is Matt Brown with another IoT hacking video. Today we are going to take another look at this Polycom conference phone that we've been doing a video series on. Today we're going to take a black box look at the web interface and see what we can do with that in terms of discovering any vulnerabilities and exploiting them. So I'm going to go right over to the screen here. If you've been following along with the other videos, you'll know that I've got the guts of this device over and on the desk. In our last video, we pulled the firmware chip off the device. I have put that firmware chip back onto the device. You can watch some of my other videos that show how you can reattach flash chips like that. Pretty easy. So I've got the device back up and running, and we are capturing its traffic here in Wireshark. I'm capturing it a little bit differently than I did last time, but that's not super important for our purposes today. So I have Wireshark open here, and we're taking a look at all the traffic that is going between this device and any other local networks or out to the internet. And so first thing we'll see here is its IP address, again, which is different than last time just because of my slightly different network setup. And so this is the IP address, 192.168.200.84, that it has received from DHCP. And so we are going to be taking a look at that. I've got Burp Suite ready, and we're going to talk through Burp Suite. If you've never used this tool before, just give an extremely quick tutorial on how to set that up. But so here you can see we've navigated to that web interface on port 80. I think there is an option to use HTTPS on port 443, but we're just going to be interacting with it the way anyone would if it's not redirecting us automatically to that secured port. Then this is probably what the average user of the system is going to use. Also, since our first video, I have probably not very wisely upgraded the firmware on this device, and then I've rolled it back to as early a firmware version as I can, and that's going to really come into play today when we talk about the vulnerabilities that are on the earlier firmware versions of this device. And so I'm going to go ahead and log in and show us what our firmware version is. So here on the Polycom, we are running firmware version 4.0.14. And so I was on a way earlier version of that before, and I poked around and I found a bunch of cool stuff, and then I upgraded it all the way to 4.0.16, and then all those vulnerabilities, they went away. Now, rolling it back to this kind of intermediate firmware, there's some of the vulnerabilities that I found in the previous one. So everything we're going to talk about today, it's definitely been fixed. So we'll talk about that in a little bit. But first, we're going to show how I have my web proxy set up here to proxy this web browser's traffic over to our other tool, which is Burp Suite. So you can see here, I've just got a simple Foxy proxy. It's an add-on in Firefox. You can do it manually in the settings as well, but this just lets me easily switch between turning the proxy off and setting the proxy here. So if I go to options, we can see what's going on here. I click into this. So really simply, I have a setting to proxy traffic to localhost port 8080. And then over here in Burp Suite, I have my proxy settings. You can see that it is listening on that same host and port. And then the key thing that you have to do, well, we don't have to today because there's no HTTPS, but if we do want to intercept any traffic that uses TLS, SSL, what you have to do is you have to export your CA certificate, and this will allow it to intercept and pretend to be the TLS web server that your web browser is connecting out to. And so what you have to do is you have to go in here and click export, certificate in dir format, click next, export that file. I'm not going to go through all those steps because I already have it set up. Then in your web browser, what you have to do is you have to go into the settings, security. This is going to be different for a different web browser. It might use your operating system cert store. Firefox has its own certificate store that is separate from the operating system. And so here in these settings, I scroll past it. No, I go to view certificate. And then under authorities, I would click import. And you can see that I've already got, I don't know, it's called like Port Swigger is the name. Here it is. So the Port Swigger CA. So this is how I'm telling my web browser, like, hey, this certificate authority, I trust it to sign all of the websites. And so that's how I can do like example.com, and that should, oh, it doesn't redirect because it's an example website. But if I were to do this, it can see that traffic, even though it'll like tell me like this site, what cert is it signed by? Port Swigger. That's not actually what example.com is signed with. So once we do that, then we can go over here into Burp Suite, close out of this. And over here in our HTTP history tab, we should see the web traffic that is coming from our web browser that is sending its traffic over to this proxy. And so here we can see all the traffic that we're interested in, that is to this IP address. And then there's a bunch of other stuff that we don't care about. So to filter out all the stuff that we don't care about, what we're going to do is going to go over here to the Target tab. Going to right click on the targets that we care about and click Add to Scope. And you can always go over here and see what is in your scope. And then we can go back to the proxy, click up on this bar, and then check this little box that says Show Only in Scope Items. And then it will get rid of anything. So now if you're doing that, then anytime you go to a news site that you do care about but is not in your scope yet, you're going to have to either uncheck this really fast, or you're going to have to go here and look at your new targets and continue to add those to your scope. So, but that gives us a nice view of only the stuff that we care about. So with that, we are going to look at this web interface. So we talked about this a little bit last time. We talked about how I received this device in a not factory reset state. So there was some proprietary information. I wanted to get rid of that so I didn't have to do a bunch of video editing and censor all those details for this video. So I factory reset the device and I upgraded the firmware. Again, that was problematic for some of our purposes today, but we will talk about that. So first of all, it's always good whenever you get an application like this, you want to understand like how does authentication work. I did not find any authentication flaws in the main core authentication mechanism of this system. It is a peculiar one, I will say. So I'm gonna hit log out so we can actually observe this. So I changed the default password to like 444. So what we're gonna do is we're gonna hit submit there, and then we're gonna go over here and actually see what that request looked like. So we can see. Actually, I need to go and let's log out again. Okay. Oh yeah, because this is the old version. Yeah, so this is a really wild form of authentication. So it's all being done in JavaScript, and then it is manually in the JavaScript, it is sending this authorization header, and you can see that, well, that would be problematic for when you reload the page. Well, it also sets an authorization cookie that it clearly just takes what's in this cookie and like copies it into the header field, right? Which is pretty interesting the way it's authenticating itself. But you'll see that it does authenticate you. And then like, if I want to say, let's like view some of the logs. Now I don't have to censor any of this. So here is a request. Wait, where'd it go? Diagnostic log, perfect. So here we can see this request that is being generated from the web application. So here we have a GET request to diagnostics logs, and it sends some query parameters. And we're seeing, again, that authorization header and this cookie being sent. It's the same thing, and if you're not familiar with how basic authentication works, this is just a base 64 encoded username : password, right? So we can right-click this, send this to the decoder. This is why it's really bad, right, that this website is, it allows HTTP and doesn't force you to HTTPS, right? Because if there was an admin using this phone and there was somebody snooping on the traffic in the middle, they would just see the username and password. So here in our decoder, we can say decode as base64, and there you can see my username and password. The username is implied, but it's just always Polycom for the admin user. So, but anyway, so here's this request. So another typical thing in Burp Suite here to do that's really helpful is if I want to like replay the request and modify things as I go along. So what I'm going to do is I'm going to right-click this request that I have. I can also right-click like anywhere here if I have the request viewed in this window, and I can say send a repeater, and then I can go and I can look in my repeater, and so I can send that request again. I get the same result. That is interesting to me that I can like get the same result more than one times, and I'm looking in here, and what I'm not seeing is any kind of CSRF token. So there's nothing in here that would prevent a cross-site request forgery attack, and that's an attack where one site, if you go to like some malicious website, like website A, that if you are logged into website B, it can make a request in JavaScript on site B on site A to site B that you're logged into, and can take some action on that site without you like hitting okay, yeah, I want to do that, anything like that. So so this entire application is vulnerable to cross-site scripting. Just gonna throw that out there right now. And so we're gonna actually do a demo of that. So here, okay, but first we want to talk about how this authentication scheme is working. So this is stuff I would do to look for auth vulns. There are none that I can find here, but it is interesting. I can completely remove that auth header and I can still authenticate. It's really this cookie that is the key thing. So if I take this cookie header away, you will see that it comes back and says, hey, you're not authorized to do this. Similarly, if I like change any of this data here, it will also be unauthorized. So it is actually, to the best that I can tell, it's actually parsing the username and password and verifying that those are the correct username and password for each request that should be behind authentication, which is everything except for the login page. So with that, we are going to go talk about the cross-site request forgery issue on this page, or on this whole device. So what I'm going to do, and what's very interesting, is the software upgrade mechanism. And so here is where I not only want to understand how the traffic between my web browser and the device is acting, but also the device to the internet. And we're going to see that here, and we're going to see more unencrypted traffic like we did last time. They don't seem to be doing a whole lot of encrypting of traffic between the phone and the internet, which seems bad, right? So here, all I'm doing is the default settings. I'm gonna say Polycom hosted server. I'm gonna like check for updates. And it says successfully fetched available software updates. Like, okay, cool. And it lists these 2 different updates that I can do. And you'll notice that there's a custom server. I can select a custom server to receive updates from, which is, that's how I was able to downgrade to a version that was not one of these 2 versions, because someone gave a download link to an older firmware that was very helpful. So first, what we're going to do is we're going to go look at this web traffic right here. Wait, is it this one? Yeah. No. This one. Here we go. And we're going to click follow HTTP stream. So here, so this is a web request from the phone out to Polycom's server out in the internet to check for an update. This is downloads.polycom.com. And so you can see that it sends this request, voice software, and this, as far as I can tell, this is like a identifying set of numbers for this device type. And so it returns this XML file that looks familiar with what we just saw in the web traffic, right? So it returns 2 kind of XML objects here, nested, a phone image, and here we can see 4.0.16, 4.0.15, and the download links of where to go get the firmware file from. And so I actually was able to use this in order to force my device to downgrade to an even lesser firmware. And we're going to demonstrate, because none of these requests have CSRF protections, right? There's no protections against a different site coming in, being forced to make a request to this phone's web server. And so how we're going to do that is I need my web server to do 2 things, actually. I need to specify my own custom server, and then I'm going to return this. So I'm going to demonstrate that. Actually, that's like a precursor to the attack. Like, you don't actually have to do that to the victim. So let's go look through this traffic for a second. All right, so custom server. Oh, cool, it's already got my custom server pre-populated here. So on my system here, so this is my desktop computer. This is another IP address that is associated with my machine, 192.168.200.1, and I am running Nginx, and I'm hosting this very file right here. And here you can see that I'm actually hosting 3 different firmware versions, and I'm hosting download links that point back to my server. Instead of some Polycom controlled server, I'm gonna point them to my Nginx server. And I have one of these files. It's actually like this one, voice, software, this whole thing, where it's hosting all of the contents that the phone looks for when it's performing its upgrade. And so we are going to go back over here, and I'm going to click check for updates. Successfully fetched available updates. And now you can see that that data is getting populated into here, right? So it is literally it's literally coming to my server here, and it's looking inside this, not that, this XML file, and it's parsing what is in these things right here. Like, I go like this. I can go A, B. So it's going to parse this XML file, and it's going to display the results back. And if you do web hacking stuff, like I do sometimes, you'll think, oh, that's interesting. That would be an interesting spot for a cross-site, or excuse me, not cross-site request forgery. It is, but cross-site scripting. And you'd be right, but I tried it, and they do sanitize for that. So we're not gonna do that demonstration here. But what I would do is I would set like an element and try to like escape the quote here, and then write some kind of property that would execute JavaScript. But tried that. They are escaping their HTML encoding correctly. So with that said, we are going to do our cross-site request forgery attack, though, and we're going to demonstrate that right now. So after so to do that, what I needed to do is understand what happens when you do click install. So let me actually do that right here. Upgrading phone to software, AAA. Well, it's not actually going to upgrade that, is it? But you can see here what it does is it does a post request to form submit, utilities, software, upgrade, upgrade. And in this version of the software, there is no CSRF token that gets submitted here to check that the user of this website actually browsed to this page and clicked on this action, instead of them getting made to send this request from another origin. So you can see here that it's gonna send the URL path and the server type. So we have crafted another file on our Nginx server to do our cross-site request forgery. So here, very stealthily named payload here. So what this is this is going to be the page that you have to, through social engineering, whatever, get the victim who is logged into this web application to navigate to this page. And so what we got here is that we have the form action. So this is where it's going to submit this post request to. And you can see it's the same thing that we had there. The URL path, again, that URL path is, actually this is, that's right. That's right. This is wrong. Okay, there we go. So the URL path is pointing to my Nginx server, where it's going to get the download, and it sets the server type of custom server. That's another one of those parameters that it needs. And then you can see here that this little piece of JavaScript, as soon as they load this page, it's going to do form.submit. So it's going to take this form and it's going to submit it, which will cause them to get directed over to the Polycom phone, and it will make this request on behalf of the victim. So good that we fixed up our payload there. All right. So now what I'm going to do is I'm actually going to go over here where I have a fresh, I should have a fresh context. Nope, I'm logged in here too. Okay, we're going to log out. I'm going to log back in. Okay, so I'm logged in as the victim, and then I got social engineered into clicking on the following link. Okay, so now we're going to observe. Actually, you know what? No, we are going to do it over here so that we can observe in Burp Suite what happens. That's actually helpful. So here you can see it loads our page, and they get redirected over to the Polycom phone, and it comes back and says upgrade success. So we can actually see what happened here. Oh, but we're going to have to, what am I doing? We're gonna have to add this to our scope so that we can actually see that part of it. Cool. So here we can see that in the web browser, first we navigated to our Nginx server running on our machine, our attacker's machine. So the victim made that request to the attacker's server, and then it got them to send a post request, this post request, to update the firmware. And looks like that is going to work. Now, it is upgrading to the very same firmware version, which is why I think it will ignore it, because I'm basically saying upgrade to the same exact version you're already on. And I think it will just kind of silently ignore that. But you can see that we did get that upgrade success response here, which proves that our attack was successful. In the later version of this phone software, there is another header in here named CSRF token, and that token does get properly validated by the phone, can't get bypassed through any methods that I know of, and so they do protect themselves from that attack. And interestingly enough, this is known, so if we go over here, so always good to look at like what CVEs are there out for an IoT device. So I just put in Polycom here, and I don't know if this is the same device, but they clearly fixed a CSRF vulnerability across the whole phone. So this says CSRF exists on Polycom QDX, which this is like a different device, but it's a different device that has the 6000 series naming convention. So I'm guessing that this does exist, and that also seemingly, yeah, like you can see the sequential numbers here. So at the same time, somebody discovered that there was stored cross-site scripting and CSRF on these phones. So this has been fixed in the latest firmware. In all the firmwares that are available for download, again, I only got the older firmware because this really awesome person here on GitHub, who is clearly doing some kind of like reverse engineering or just like understanding of this exact device. They had this download link that did still work right here for 4.0.14. So 4.0.14, it did still have the CSRF vulnerability in it. There are some other things that it did have fixed. In the really old version of the firmware, for example, this is always great stuff to check. So I was originally going to do my CSRF demo with this change password field, but you have to know the old password to change the new password. Well, in the really old versions of the firmware, they never checked the old password. It just submitted the new password on to be changed. So all you had to do is make sure the new password and confirm new password were the same. It did absolutely nothing. It did no validation with the old password at all on an older version of this phone firmware. So, so that's just a little bit of the web stuff that I do when I'm looking at an IoT device like this. I am probably going to do one more video where I kind of go back to the firmware and test out some firmware modification. This device may verify a signature when the firmware is loaded, and it might make modifying the firmware pretty hard, but I am going to test some more of those hardware-based attacks against the device. I also discovered, I got a lot of really good comments on my last video. I did discover this is not a Linux-based device. This is a RTOS or a microcontroller-based device, and so that does reduce what I can do in terms of like unpacking file systems. There's no file system in the kind of traditional operating system sense of that word. So I hope this was a fun video, getting to dig into a little bit of web hacking on an IoT device like this. Please comment, like, and subscribe to these videos, and have a good day.